accordance with Le Chatelier's principle, an increase in pressure favours the formation of ammonia by a shift in the equilibrium. The higher the pressure used, the better the product yield will be. An increase in temperature speeds up the reaction, but at the same time reduces the yield of ammonia because of the exothermic character of this reaction. For example, at 25 degrees centigrade and under atmospheric pressure, the reaction equilibrium is totally oriented towards the formation of ammonia, K equals 6 times 10 to the power of 5, but the reaction rate is practically zero under these conditions. Research proved that it was impossible to match the conditions of temperature and pressure in a way that would ensure a sufficient reaction rate and the efficiency of the process. The creator of this method of ammonia production, Fritz Haber, dedicated most of his efforts to the search for and development of an appropriate catalyst for speeding up the reaction. Nowadays, two types of catalysts are employed. One consists of specially prepared iron activated with aluminium and potassium oxides. The other one is finely divided ruthenium on graphite. The ammonia produced is absorbed in water or condensed, while the unreacted hydrogen and nitrogen are recycled to be used again in the production of ammonia.
Haber process. Just now the video is about Haber process. It's the industrial preparation of ammonia. This is the chemical equation with the enthalpy negative value, which is exothermic. How to maximize yield of ammonia? First of all, we will check the phase of the chemical equation, gas, gas, gas. Okay, so total there are 4 mole of reactants over left hand side and 2 mole of product over right hand side. This reaction is an exothermic reaction, that's why heat is added at the product side. If we want to maximize the yield of ammonia, we have to look at the main 4 factors, but over here we exclude catalyst. So the first one, concentration, we try to reduce the concentration of ammonia in order to produce more ammonia. Next, volume. Okay, since the equilibrium position need to shift to the right side, means from more number of mole to fewer number of mole. So the system need to reduce volume and increase pressure. Then equilibrium shift towards fewer mole of gas. Then form more ammonia. The third point about temperature. In this case, forward reaction can produce more ammonia. So, and for this forward reaction is exothermic. Exothermic is favor low temperature. However, we need to consider few points. High pressure and continuous removal of ammonia are used to increase yield, but the temperature is raised to moderate level, not low level. Okay, and a catalyst is used to increase the rate. Because in order to achieve the same rate without a catalyst, require much higher temperature and result in a much lower yield. Because when high temperature, the system will shift it to left. So the concentration of ammonia is decreased. The yield is favored by low temperature, but the rate formation is not. In fact, ammonia forms so slowly at low temperature that the process becomes uneconomical. Let's check for this exercise. Lime calcium oxide used primarily in the manufacture of steel, glass, and high-quality paper. It is produced in an endothermic reaction by thermal decomposition limestone. Okay, how to increase the maximum amount of lime over here? So means the system need to shift it to the right side. So based on this equation, we have to do the same thing. First, check. Okay, this is endothermic reaction. That's why the heat is over reactant side. And then solid, we just ignore over here. the number of mole here is equal to 0. And then for the right hand side, okay, this one is solid, but our purpose is produce more calcium oxide, means we have to ensure that the system is shifted to the right. CO2 1 mole because 1 mole of gas over here. Okay. The composition reaction is endothermic. Ideal condition to maximize the production of calcium oxide again is shifted. The equilibrium position have to shift to the right side. So how to shift to the right side? So if I want to shift to the right side, in this case endothermic reaction is favorable, so have to increase the temperature. And then 0 to 1 means from fewer number of mole to high number of mole, means have to have low pressure and high volume, so that the system equilibrium position can shift to the side with more number of mole of gas. And then the next, we can remove the concentration of CO2 continuously, so the system will shift to the right. Next is tutorial discussion. Question 15. Consider the following equilibrium system. The chemical equation is given. So step 1, we need to identify the phase. So all of them are gas, homogeneous, okay? So have to consider all the substance. Over reactant, there are 7 mole, total is 7 mole. And then over product, total there are 8 moles. And then the enthalpy is negative value, means exothermic. So the heat is added at the product side. So now check, the question asks, determine the direction, means shift to the left or shift to the right. Okay, to re-establish equilibrium if the system is disturbed by, okay, number 1, adding concentration of oxygen. Actually, the answer is simple. You just answer left or right, that's all. But for our discussion, I will discuss in details. Okay, first, adding oxygen means the concentration of oxygen increase. Q is different with K, means the system now is not at equilibrium. So we try to reduce the disturbance by reduce the concentration of oxygen. Then how to reduce the concentration of oxygen? The equilibrium position will shift it to the right side. Okay, when the equilibrium position shift to the right side, the concentration of nitrogen and steam increase. Then the concentration of oxygen and ammonia decrease. Equilibrium remain unchanged because Kc is not affected by concentration. Number 2, removing ammonia means the concentration of ammonia decrease. The system now is not at equilibrium. So the system try to reduce the disturbance by increase the concentration of ammonia. If we want to increase the concentration of ammonia, the system have to shift to the left. When the equilibrium position shift to the left, the concentration of ammonia and oxygen increase, and then the concentration of the product, means nitrogen and water, no, not water, steam, is decreased. Okay, again, the Kc value remain unchanged. Number 3, increasing the temperature. In this case, the forward reaction is exothermic. If increasing the temperature, endothermic reaction is favorable. So the equilibrium position will shift to the left. The equilibrium shift to the left means more concentration is produced. More reactant will produce. The concentration of the reactant increase. Okay, so the concentration of ammonia, oxygen increase. Automatically, the concentration of the product, means nitrogen and steam, is decreased. Then, the Kc value decrease. Okay, question number 16. Decomposition of ethane produce ethene and hydrogen gas. Again, first of all, check the phase. And then over reactant, there is 1 mole. Over products, there are 2 mole. And then the enthalpy is positive, means endothermic. So heat is added to the reactant side. By using Le Chatelier principle, explain the shift in equilibrium position. If any of the reaction okay, so A, B, C, D, E, F, G, H, total there are 8 questions. Let's solve one by one. The concentration of hydrogen gas decrease. So hydrogen gas decrease. Now the system will try to increase back the concentration of hydrogen. Okay, means okay, the system have to shift to the right side, okay, to help increase, okay, to re-establish the equilibrium but increase the concentration of hydrogen gas. B, temperature is lower. If temperature is lower, means exothermic reaction is favorable. For this case is endo. So if I want exo means I have to shift to the left. Okay, the position equilibrium will re-establish, try to increase the heat by shifting to the left. Okay, C, add catalyst. This one simple answer, no change. But you have to explain why no change. Because the function of catalyst is speed up the chemical reaction by provide an alternative pathway with lower activation energy. D, about concentration, ethane means over here the reactant is decreased, means remove. Now the concentration of ethane is decreased, so the system try to increase C2H6. How to increase C2H6? So the system have to, the equilibrium position have to shifted to left here in order to increase the concentration of C2H6 or produce more C2H6. Okay, now E. Okay, E volume increase means pressure decrease. F, pressure is increased, volume is decreased, meaning that E and F is different. Okay, one is about volume increase, pressure decrease, and then F is about pressure increase, volume decrease. As we know, we have to check for the number of mole. Okay, when volume increase, big house, still remember big house, I want party, I want to find more friends. So for E, we'll shift it to the side with more number of mole. Okay, so we check E, yes, shifted to the right side. When the volume increase, the pressure decrease, the equilibrium will re-establish by shifted to the side with more mole of gases to increase the pressure. Automatically left for F because pressure increase, okay, congested. So remember, the traffic is congested. You will try to find somewhere that less car. So for this question, the answer will be left because it will shifted from 2 to 1. The equilibrium will re-establish by shifted to the side with fewer mole of gases to decrease the additional pressure. Okay, G and F is about an inert gas. About inert gas added at constant pressure and constant volume. For constant pressure means, okay, the total of the P total must be the same, meaning that the partial pressure of the non-reactant gases will be decreased. Okay, so the overall pressure of the equilibrium mixture, okay, will decrease. That's why the equilibrium position will shift side with more mole of gases to increase the pressure of the system. Last one, no change because due to adding of inert gas at constant volume does not change the partial pressure of the substance involved in the reaction. This is the last question for tutorial chapter 6. Nitrogen tetraoxide dimerize as follows. First of all, identify, check the phase of the equation first. Yes, gas. So there are 2 mole at the reactant side and 1 mole at the product side. And then this chemical equation is negative enthalpy, meaning that exothermic. So heat is added at the product side. Heat is released. Okay, so forward reaction is exo. Automatically the reverse reaction is endo. So in this case, we need to explain how the product could be increased. So if I want the product to increase, means the system have to shift it to right side. In this case, we have to explain based on 3 factors. The first one about concentration. So for concentration, if I want the system equilibrium shifted to right side, so I must increase the concentration of NO2 by adding more NO2 and decrease the concentration of N2O4 by remove N2O4. Then the equilibrium position will shift to the right to increase concentration of product N2O4. Next, for temperature, since this forward reaction is exothermic, and then the reaction exothermic is favor low temperature, so need to decrease temperature. Okay, because the exothermic reaction favor low temperature. So the equilibrium position will shift to the right to increase the concentration of N2O4. Next, about pressure and volume, from high number of moles shifted to fewer number of moles. Means in this case, the system needs to increase pressure, decrease volume. Then the equilibrium position will shift to the side with fewer number of moles. Then the equilibrium position will shift to the right to increase N2O4. This is the answer for objective question. Please remember, must show the working, calculation, explanation in your tutorial book for all the objective question. Then submit your Chapter 6 tutorial via Google Classroom. You must try all these questions because this question might help you answer UPS 3. If got any question, please don't hesitate to contact me, Madam Kong, through WhatsApp or Google Meet. Thank you. Don't give up. Thank you for watching this video. Please do remember, subscribe, like, and share this channel. Bye.